Good morning everyone. I am Jahnavi bearing ID number 20000031422 and today I am going to explain about guided backpropagation, which is part of my peer mentoring task. Let us see what is guided backpropagation. For this, firstly, what is backpropagation? Backpropagation is a supervised learning algorithm used in neural network for training models to make predictions. It is used to update the weights and biases of a neural network in order to minimize the error between the predicted output and the actual output of a given input. And during the forward pass of a backpropagation, the input is passed through the neural network and the output is compared to the desired output to calculate the error. During the backward pass, the error is propagated back through the network and the weights and biases are adjusted using a gradient descent algorithm. Backpropagation works by calculating the gradient of the error with respect to each weight and bias in the network and adjusting them in the direction of the negative gradient. This process is repeated over many iterations until the network reaches a state where the error is minimized and the model can accurately make predictions for new input data. Backpropagation is a powerful tool for training neural networks and has been used in many applications such as image recognition, natural language processing, and speech recognition. This is about backpropagation. And now let us see what is guided propagation. Guided propagation is the combination of vanilla backpropagation at ReLUs and deconvnets. ReLU is an activation function that deactivates the negative neurons. Vanilla backpropagation works by first passing an input through the network, calculating the output of each neuron in the network. The error obtained between the predicted output and the true output is then calculated and usually using a loss function such as mean squared error or cross entropy. And now coming to deconvnets, these are simply the deconvolutional and unpooling layers. We are only interested in knowing what image features the neuron detects. So, when propagating the gradient, we set all the negative gradients to 0. We don't care if a pixel suppresses, that is negative value, a neuron somewhere along the path to our neuron. Value in the filter map greater than 0 signifies the pixel importance, which is overlapped with the input image to show which pixel from the input image is contributing the most. And now let's see how this guided propagation works. Similar to GradCam, guided propagation, backpropagation is a gradient-based visualization technique. Given an input image and a pre-trained network, guided backpropagation can tell us which pixel in the input image matters for the correct classification. And it is called guided backpropagation because we chose a guide which neurons are to be activated for the backpropagation. And to perform this, firstly we do a forward pass to the layer that we are interested in. Here in this image you can see the input image is given into the neural network and that input image is converted into a matrix. After conversion into matrix, this means that if the input values in the previous layer are negative, for suppose some values are negative, the output after the ReLU operation is set to 0. So after applying ReLU function, the negative values in the matrix are changed to 0. As you can see here, after forward pass, here the negative values are -1, -5, -7 and -3. So after applying ReLU function, these negative values which are marked as red are converted to 0. And next, for the ReLU, when we do a traditional backpropagation, it passes gradient to a previous layer only if the original input was positive. So this is forward pass and this is backward pass, and after applying gradients, this is the matrix and for the first layer, and this is the matrix for the second layer. And after applying all the gradients, as shown, the gradients for the dead neurons are set to 0. In the case of guided backpropagation, we also do not backpass the negative gradients to the previous layer. So after that, the values which are 0 and negative are not backpass because they doesn't give any positive value, so they are not included in the backpass. So here you can see the gradients for both the red and yellow neurons are not back propagated. And after this, again we'll recap our forward pass, which is the input is given into the neural network and the input is changed to a matrix. The main reason for changing into the matrix because the computers can easily understand numbers than images, so the image is converted into the matrix. And finally, suppose we are only interested in the neuron at the right bottom corner, which has the gradient value 2, we can retain this neuron and set all other neurons to 0. Like we can only choose the ones which we are interested in. So then the gradient for the chosen neuron is backpropagated all the way to the inputs to get a reconstructed. So here, except like negative numbers and zeros, for suppose if you want only positive numbers, only those values are reconstructed using back pass. And next, we have talked about how to choose a neuron for guided backpropagation above. That is, in the guided propagation, the backpropagation logic is this. So, for choosing the guide, we use this following formula. And now let's see how to implement guided backpropagation. First, we will import all the necessary libraries that we are going to import to make a model. After that, we will load the image which we are going to change it. And next, now we will build an LXNet model for applying guided backpropagation. And now let us preprocess the image by using LXNet's preprocess function. And after that, we'll import LXNet transferred learning model on the ImageNet dataset. After that, we will create a model until the last convolutional layer from the imported LXNet transferred learning model. When we use the fully connected layer in the deep learning CNN model, we lose the spatial information which is retained by convolutional layers. And next, when we apply gradients of ReLU, they are overridden by applying the ReLU function that allows the fine-grained control over the gradients for backpropagating non-negative gradients to have more efficient or numerically stable gradient. Applying the guided ReLU function to all the convolutional layers whenever the activation function was ReLU. And finally, applying all these steps, we can visualize the original image and guided backpropagated image. And now we have seen the steps to implement, and now we can see the code. Here is the explanation to code. See, first we have imported some libraries which are necessary, and after that we have initialized a function named guided backprop. And after that we have in guided propagation we apply two passes, that is forward pass and backward pass, in order to choose the best guide. So for that we need to initialize two passes, that is forward pass and backward pass. And after that we have constructed an LXNet model in order to implement guided backpropagation architecture. And after that same in the LXNet model, usually we have many layers in order to filter the image and to find the best guide. We'll have layers like convolutional layer, pooling layer, max pool layer, con2d layer. So these all layers help in pre-processing the image and finding the best guide. And after that we also have initialized visual function. This is also important for visualizing the image and to find which pixel is more important for the classification. And similarly we have also initialized normalized function, and these are some rules like how to normalize the image. And after that here we have loaded the image. And next, so after all the process, we have printed the original image and the guided back propagated image. And after running this, here you can see that the image is pre-processed through many layers, that is con 2D layer, ReLU, and the ReLU activation function plays an important role in normalizing the image. And here you can see max pool 2D, max pool 2D, and conv 2D. So here these are the layers through which image is pre-processed. And so here you can see this is the original image and this is the back propagated image. So this is all about guided back propagation. Thank you.